In this lesson, we're going to learn how to find the equation of a tangent and a normal to a curve. To be able to do this, we need to remember how to find the equation of a line from a gradient and a point. We need to be able to find the gradient of the line using differentiation. We need to remember how to find the perpendicular gradient, and then we can put it all together using the formula y minus y1 equals x minus x1 to find the gradient of the tangent and the normal. As a starter and a reminder of how to find the equation of a line from a gradient and a point, I want you to have a go at these questions. Find all the equations in the form y equals mx plus c. And remember here we're using the equation y minus y1 equals x minus x1 by substituting in the gradient and the x and y coordinate. We can rearrange and find the equation of the line in the form y equals mx plus c. So pause the video and have a go at these three questions. So the answers you should have are y equals 3x plus 1, y equals 2x minus 4, and y equals minus 2x minus 3. So a tangent we've come across before. A tangent is a straight line that touches a curve at a particular point. So here is our tangent in blue to the curve which is in green. A normal then is a straight line that is 90 degrees to the tangent. So there is our tangent at a particular point in blue, and the normal is just the line that is at the same point on the curve but at 90 degrees to the tangent. So as we've had a reminder in our starter, in order to find the equation of any straight line, we need the gradient of that line and we need a point on that line. And then we simply substitute into y minus y1 equals x minus x1. So you'll find this notes sheet in Teams and you can write down the next few examples. So the only difference now is the fact that we're going to use differentiation to find dy by dx to find the gradient of the tangent at that particular point to use in the equation y minus y1 equals x minus x1. We're going to follow through these steps to have a go at finding the equation of a tangent. If we're given the x coordinate at the point we want the equation of the tangent, we can find the y coordinate of that point by substituting it into the equation of a curve. We're then going to differentiate to find the gradient function of that curve and substitute the x coordinate to find the gradient at the particular point. Then we're going to use y minus y1 equals x minus x1 to find the equation of the tangent in whatever form the question asks us to. So let's use those steps to find the equation of the tangent at the point x equals 1 to the curve x squared plus 3x minus 2. And it wants it in this particular form, ax plus by plus c equals 0. So first thing we're going to do, step 1, is we're going to find the y coordinate. So when x equals 1, substituting in to the equation of the curve, we can find the y coordinate. And we get the y coordinate is equal to 2. So we know that our point therefore is 1, 2. For the next step, we're going to differentiate and find the gradient function of this quadratic curve and then substitute x equals 1 to find the gradient at x equals 1. So differentiating x squared plus 3x minus 2 gives us 2x plus 3. So that's my gradient function. I want the gradient at x equals 1. So let's substitute x equals 1 into our gradient function. We get 2 plus 3 equals 5. So that means that we know that the gradient at x equals 5, the gradient at x equals 1 is equal to 5. So we know the gradient of our tangent is equal to 5. So what we're going to do finally is find the equation of the tangent using y minus y1 equals x minus x1. So we know the gradient of the tangent is equal to 5, and we've got a point on the tangent. We know that the point here, 1, 2, lies on the tangent. So we're going to substitute those into here. So that actually is an equation for the tangent, but it wants it in this particular form. So let's just do a little bit of rearranging. So I'm going to expand the brackets. And if we have a look at that form again, it wants the x term, the y term, and the numerical term all on one side of the equal sign, with everything else equaling 0. And we want to make that x term positive, seeing as that's at the beginning of that expression on the left hand side. So I'm going to keep the x term here on the right because that's what's going to keep it positive. I'm going to take the y over the other side, and I'm going to take the minus 2 over the other side, and adding it gives me minus 3. So the left hand side there equals 0. We could swap onto the other side, but that is my form: ax plus by plus c equals 0. That's the equation of my tangent. So if we want to find the equation of the normal at the point x equals 1, so here we are, we've got the normal, it's the dashed line, it's perpendicular to the tangent. All we need to do is to add one extra step into our workings to find the perpendicular gradient. So in this question we're just using the same curve. So the equation of our curve was y equals x squared plus 3x minus 2. So we've already found the y coordinate. So we're getting the equation of the normal at the point 1, 2. Now, if you remember, in part A, we found the gradient of the tangent at this point was equal to 5. Therefore, we know that the gradient of the normal is equal to minus 1/5, using the perpendicular gradient is the negative reciprocal. So all we need to do now is go straight to the step 3 and find the equation of the normal by substituting my point and my gradient of my normal. So we're going to put m capital N there, that's what I use for the gradient of the normal, into y minus y1 m x minus x1. So I've got y minus 2 equals minus 1/5 this time, x minus 1. Again, we want it in a particular form. This time we can say we want all the x terms and all the y terms on one side of the equal and the constant on the other side. We're going to keep the x term positive again because it's at the beginning of the expression on the left hand side. So the first thing I'm going to do here is get rid of the fraction by multiplying both sides by 5. And I'm going to expand these brackets. Then I'm going to get the x term, so let's take the x term over to the left hand side with the y term and take the minus 10 over to the right hand side. So I end up with x plus 5y equals 11 with my equation in the right form. If a question asks for an equation of a line in a particular form, you do need to put it in that form to get the full accuracy marks. So that's how we find the equation of the tangent and normal. What we're just going to have a quick look at now is some problem solving tips, because we're going to get on to some problem solving questions and a reminder how we do some of these things when working with coordinate geometry. So if we wanted to find the intersection of the curve with the x-axis, or the x-intercept, what we would need to do is substitute y equals 0 into the equation of the curve. Similarly, if we wanted to find the intersection of the curve with the y-axis, i.e. the y-intercept, we could substitute x equals 0 into the equation of the curve. If we're told that a tangent is parallel to the x-axis, we know that that's a horizontal line, therefore it has a gradient that is equal to 0. Remember also, if we need to find the points of intersection between a curve and a line, so we'll have the equation of the curve and the equation of the line, or if we don't have them, we'd need to find the equation of the curve and find the equation of the line, and then to find out where they cross, we need to solve their equations simultaneously to find the points of intersection. And the final tip, if a question involves shapes, so sometimes within coordinate geometry you can have lines that, for example, create a triangle and need to find the area of that triangle, the most important thing to do is to draw a diagram. It doesn't need to be an accurate diagram with scale and on your axes, it's just a sketch, but you must draw a diagram so you can see exactly what's going on. So now I'd like you to have a go at exercise 8C in the Further Maths textbook on page 219. And there's a scan of an exercise from the A-level textbook if you finish that and you need some extension.